This is the 5th section of the Exponentials and Logarithms chapter, and this is all about the laws of logarithms that allow us to put logarithms together. And they're similar to like the laws for powers. So for example, multiplying means that we add, like when you multiply things, you add the powers. Dividing means you subtract, which is a bit like when you subtract the powers. And when you have a power of a power, you multiply. Yeah, so here we've got like a power of a power there. And there are some special cases here when you've got the log of 1 over x. That's the same as x to the power negative 1 here. And that negative 1 can go at the front there. It does the same thing. And this, well, if you've got something like this, the power that takes you from a to 8 is 1. And the power that takes you from a number to 1 is 0. So these are sort of special cases here. So you could think of this as actually being another way of stating this, and this as being another way of stating this statement here. First example here, log base 3 6 plus log base 3 7. Right, so the rule for adding is that you multiply. And notice the base has to be the same, so this is the same as log to the base 3, 6 times 7. So that's the same as log to the base 3, 6 times 7, 42. Next one, part B, log to the base 2, 15, minus log to the base 2, 3. So that's the same as log to the base 2 of 15 divided by 3, which is log to the base 2, 5. C, log to, alright, okay, there's a 2 there, sorry. 2 log base 5, 3 plus 3 log base 5, 2. Right, we've got a number at the front. That becomes the power, so it's log to the base 5, 3 squared plus log to the base 5, 2 cubed. So that's log to the base 5, 9 plus log to the base 5, 8. Okay, so after that, that's log to the base 5 of 9 times 8, which is log to the base 5, 72. And the last one, D, so log to the base 10, 3 minus 4 log to the base 10. Now that half I'm going to write as 2 to the power negative 1, like this. Okay, so that becomes log base 10, 3 minus log to the base 10. Now we've got 2 to the negative 1 to the power 4 becomes a power. Now, whenever we have log to the base 10, because we use it so often, because we work in base 10, you can just write log. Yeah, and it's assumed that it's log to the base 10. Right, so that's log to the base 3, or sorry, log to the base 10 of 3 minus log to the base 10. That will become 2 to the power negative 4. So put them together, log to the base 10, that's 3 divided by 2 to the power negative 4. And that becomes, well, 3 divided by 1 over 16, which finally leaves you with log to the base 10, 48. So let's put those, highlight those answers there. Right, in terms of log base ax, log base ay, log base a z. Right, so the first one what we can do is so we can split these up into multiplications. Plus log base AY plus log base AZ cubed. Now the powers can go at the front, so you've got 2 log base AX plus, there's no power there, log base AY plus 3 log base AZ. So that's part A done. Part B, where we've got log to the base A of x over y cubed. So we can write that as a subtraction. So that's log to the base A x minus log to the base A y cubed, and that power is going to go to the front. So 3 log to the base A y. And for C, we've got log of this x root y over z. Right, so that's the same as log to the base A of x plus log to the base A of root y, which is y to the power half, minus log to the base A, because we're dividing x, and then z, sorry, and then finally we'll just put the half at the front, the power. Like that. And the last one, D, which is log to the base A of x over A to the power 4. So that's log to the base A of x minus log to the base A of A to the power 4. Now, what's the power that takes you from A to the power 4? 4. So actually, it's just log to the base A of x minus 4. So again, like the previous one, just highlight the answers. So these are all in terms of log AX, log AY, or log AZ. Right, so we've got this equation we want to solve. What we're going to do is we're going to use the rules of logs to put this all together. So you've got log base 10 4 plus 2 log base 10x equals 2. So I'm going to move the 2 so that it's the power, so it becomes x squared, like that. That allows me to put these two logs together as a single one, log to the base x, or 10 of 4 times x squared equals 2. Now what we need to do is to convert this log back into a power. So basically the power that takes you from 10 to 4x squared is 2. So that means 10 squared equals 4x squared. So that's going to be 100, isn't it? Divided by 4. So I've got 25 equals x squared, which then means that x is 5. X is 5. Now the reason we don't have negative 5 is that you can't do the log of a negative number. Yeah, and I've got an x there and I can't do the log of a negative number, so it might be worth just making a note of that. Okay, so we cannot do the log, whatever base it is, let's call it base n of a negative number. It's not defined for it. It will just come up error on your calculator. Let's solve this equation. Log to the base 3 of x plus 11 minus log to the base 3 x minus 5 equals 2. So there are no powers to put at the front. but we put the two logs together, log to the base 3, and this is going to be x plus 11 divided by x minus 5 equals 2. Now we write this as powers, so it's 3 squared equals x plus 11 over x minus 5. So basically x plus 11 over x minus 5 equals 9. From here we can times both sides by x minus 5, so we've got x plus 11 equals 9x minus 45. Take x away from both sides, so we've got 8x 8x minus 45 equals 11, and then take away 45 from both sides, so 8x equals, I should know what 11 minus 45 is, or plus 45. Oh, that's easy, it's 56. So that means that x equals 7 if I've learnt my timetables right. You should now be able to do exercise 14E on pages 323 to 324. The laws of logs are here, but you do need to remember them. Yeah, and it just comes with practice. Practice lots of questions, you'll remember these rules off by heart.